our next separating technique, and this is fractional distillation. And what you may notice is this apparatus is very similar to simple distillation, and it is. It just has one extra addition, and that is this piece of apparatus, which is called the fractionating column, and we'll talk about that in a wee second. So what fractional distillation is used to separate is a different type of mixture. It's used to separate miscible liquids. That means liquids that mix together. And the principle behind this is that the liquids in the mixture have different boiling points, so they will evaporate at different temperatures, and that's really important for this process to work. So what we've got in our round bottom flask here is a mixture of ethanol and water, and right now it just looks like one liquid, one colourless liquid. You could look at that and think, well, there's just water in there. But actually there's ethanol and water, both colourless liquids, and because they're miscible, they mix together and form one layer. So what's going to happen in this process? Well, what is going to happen is I'm going to turn the heat on, the Bunsen burner on, and that will cause our mixture to increase in temperature. And when we get to the boiling point of the liquid in the mixture that has the lower boiling point, so remember I said the two liquids have to have different boiling points. So the one with the lower boiling point, in this case ethanol, will evaporate first. Ethanol will evaporate at about 79 degrees C. So that will start to evaporate, and it will pass up the fractionating column. And the fractionating column is there just to make sure that any of the water particles that have managed to escape as a gas below their boiling point, they will then condense because they don't have quite enough energy and fall back into the mixture. But our ethanol particles at 79 degrees C will make it all the way to the top of the fractionating column. They will pass into the condenser, and just as we had before, we'll have cold water running around the outside of the condenser, and so the ethanol vapour passes through into the condenser, will condense into a liquid, and then will be collected in this flask. And we can do that until all of the ethanol has separated off. And what we'll see in the thermometer is really important in this process, is the thermometer will read the boiling point of the liquid with the lower boiling point. So in this case, it will read 79 degrees C for ethanol, and it will stay at that temperature as all the ethanol passes through the condenser. And once we see that temperature start to rise, we'll know that we've removed all of the ethanol, and we simply swap this flask for a clean flask, and then we can wait for the water to separate across as well. Okay, so this method works on the principle that the liquids in our mixture have different boiling points, so we collect them at different temperatures, and once we've collected them in different flasks, we call them fractions. And that's why this is called fractional distillation. So let's get this going. Again, we've got water in at the bottom, water out at the top in our condenser. So let me turn the cold water tap on. So you can see that pushing up your condenser and then coming out the bottom. So we'll let that water flow through, and remember that's to cool the gases. Let me switch around to this side, and I'm going to turn my Bunsen burner on. Okay, and I'll put it on roughly the half open, half closed because we're heating liquids. And again, our round bottom flask contains anti-bumping granules to promote smooth boiling. We don't want it boiling too vigorously, essentially. The temperature of my thermometer at the minute is about 23 degrees, which is roughly room temperature. But as you'll see, as our vapours start to pass across the thermometer, then we will it'll read a higher temperature. So remember, the position of that bulb is really important. It must be at this junction where the gas is passing into the condenser, so that we can know the temperature of the gas that's passing across. And that's even more important in this process, because we need to know the temperature of the gas that we're collecting at the different stages of this process. So let me just remind you what's happening. We're starting to increase the temperature of our mixture at this point, and once we get to the boiling point of ethanol, our liquid that has the lower boiling point, then the ethanol will start to evaporate off, will pass into the fractionating column. And remember, the point of that piece of apparatus is just to allow better separation of our components within our mixture. So if we didn't have that there, it might be quite easy for the ethanol and water to separate off together, because some of the water particles might have enough energy below their boiling point to evaporate as a gas. And if they're passing straight into the condenser, we could end up with, again, a mixture collected. But what we want is to make sure that our fractions are pure. They only contain one of the liquids in our mixture. So you can start to see a little bit happening here in our round bottom flask, a bit of condensation forming around the top of the round bottom flask. And hopefully shortly you will see some gases rising up into the fractionating column. Okay. And you can start to actually see some of liquid dropping down from the fractionating column, and that's because some of our gas particles have got enough energy to evaporate. Some of our liquid particles, sorry, have got enough energy to evaporate as a gas, but then as they meet this cool fractionating column, they condense again and fall back into our solution, our mixture, and that's really important, so that we're not getting any water evaporating off when we just want to collect the ethanol. But as the temperature rises, as our particles get even more energy, they will have enough energy to stay as a gas and pass the whole way up the fractionating column and into the condenser. So I'm not sure if you can see, but I can start to see the vapour rising to about this point, and it's now starting to pass through into the condenser. But actually it's already a liquid at this point, so a lot of it has lost its energy as it has passed through the fractionating column. So as you can see, our temperature's about 74 degrees at the minute, but we have a little bit of ethanol collecting over it. Wouldn't be a high enough temperature for our water, but some of our ethanol has got enough energy to evaporate as a gas, pass into the condenser, and is now being collected in our first flask. Okay. So you can see the mixture boiling a lot more now. But as this temperature stays nice and consistent and stays the same, it will stay at the same temperature until we have separated all the ethanol across. And then when we start to see the temperature rise again, we know that, okay, that's all of the ethanol gone, and I can switch my flask to the water. So we'll maybe leave that going for a couple of minutes while we separate the ethanol, and then we'll start again to see the water coming across. So what we can see now is that the temperature is going well above 80, so it's well past the boiling point of our ethanol. We're probably just collecting our last few drops of ethanol in our flask at the minute. But what we want to do before we get any water collected off, I'm just going to take the Bunsen burner off here a wee second. We want to switch this over so that we can collect our water in a clean flask, okay? So what I'm going to do is tilt this a wee bit, separate that flask off, and quickly change that for a fresh flask and continue to heat. And what we'll see now is that our temperature will start to rise. We're at about 86 already, so some of our water might have got enough energy to separate off, but you can see those drops have stopped at the minute. So we'll heat it a little bit more. And so after the temperature has risen past the boiling point of ethanol, then we know that all the ethanol has been collected. So in this flask here, I'll not take it too close to the Bunsen burner, this is pure ethanol. And I know you can't smell it in the video, but it has a really strong smell of ethanol, a bit like your hand sanitizer and things like that that are used in cleaning substances and sanitizing substances. So that is our ethanol. I'll put this right over here so that it's not near the Bunsen burner, because obviously ethanol is very flammable. And what you can see now is that we've got a few drops coming over into our flask. The temperature is about 90 degrees, so it is a wee bit lower than the boiling point of water, but just some of that has managed to have enough energy. You can see it's quite slow drops at this point. So what will happen now is that the temperature of this liquid will start to increase now that the ethanol is evaporated away, and it will increase until we get to about 100 degrees C, and that's when we'll see most of our water evaporating, passing through into the condenser as steam. But then because of the cool water flowing around the outside, it will condense into a liquid, and we're collecting it now in a clean, separate flask. And this is what we call a fraction. So our first fraction was our ethanol, so that's our first fraction, and it's separated off first because it has the lower boiling point. Water has a higher boiling point, and so it's separated in a clean flask, collected in a clean flask as our second fraction. And these two liquids are now pure because they're not mixed with anything else. And we can use fractional distillation to separate more than two liquids. We would just need another container to collect our third fraction. Again, it would have a higher boiling point again. And next year you'll look at something called fractional distillation of crude oil, and that's where you have lots and lots of different liquids within your mixtures that you separate at different fractions. So that's the process of fractional distillation. We can leave that now until all the water has separated off, and it is used to separate two or more miscible liquids.